Why Pluto is no longer a planet. The real scientific reason. For decades, Pluto was taught as the ninth planet of our solar system. Many of us grew up memorizing it alongside Mercury, Venus, Earth, and the other planets. It held a special place, distant, mysterious, and different from the rest. Then, in 2006, Pluto lost its planetary status. This decision surprised the public and sparked debate worldwide. But contrary to popular belief, it was not emotional, political, or arbitrary. It was based entirely on science, on how our understanding of the solar system evolved with better data. So today, let's clearly and calmly understand why Pluto is no longer considered a planet, what changed in astronomy, and whether Pluto was ever truly a planet in the scientific sense. Pluto was discovered in 1930 by American astronomer Clyde Tombaugh. At the time, astronomers were searching for a hypothetical object called Planet X, believed to be disturbing Neptune's orbit through gravitational influence. When Tombaugh identified Pluto, it appeared to fit the expectations of a distant planet, and it was immediately classified as the ninth planet. However, early telescopes were limited. Pluto appeared larger and more massive than it actually is. For decades, astronomers assumed Pluto was comparable to Earth or Mars in size. That assumption turned out to be incorrect. As telescope technology improved in the late 20th century, scientists began measuring Pluto more precisely. What they discovered raised serious concerns about its planetary status. First, Pluto is extremely small, smaller than Earth's moon. Second, its orbit is unusual. Unlike the nearly flat, circular orbits of the 8 major planets, Pluto follows a highly elliptical and tilted path around the Sun. In fact, for part of its orbit, Pluto comes closer to the Sun than Neptune. Most importantly, Pluto does not exist alone. It resides in a vast region beyond Neptune called the Kuiper Belt, a disk-shaped zone filled with icy bodies left over from the formation of the solar system. Many of these objects are similar to Pluto in size and composition. This created a critical scientific problem. If Pluto is a planet, then what about the dozens, possibly hundreds, of similar objects in the same region? Should they all be planets too? By the early 2000s, astronomers began discovering Kuiper Belt objects nearly as large as Pluto, including one called Eris, which is actually slightly more massive. This forced scientists to confront an unavoidable question. What exactly defines a planet? In 2006, the International Astronomical Union, the global authority responsible for astronomical classifications, introduced a formal scientific definition of a planet. According to this definition, a planet must meet 3 conditions. First, it must orbit the Sun. Second, it must be massive enough for gravity to pull it into a nearly round shape. Third, and this is the decisive factor, it must have cleared its orbital neighborhood. Clearing the orbit means that a planet must be gravitationally dominant, having removed or controlled most other objects near its path through collisions, capture, or ejection. Pluto meets the first 2 conditions. It orbits the Sun, and it is spherical due to its gravity. But it fails the third. Pluto has not cleared its orbital neighborhood. It shares its region with countless Kuiper Belt objects of comparable size. It does not dominate its orbit the way Earth, Jupiter, or even Neptune does. Because of this, Pluto was reclassified as a dwarf planet. This reclassification was not a punishment or a downgrade. It was a refinement, an adjustment made to maintain consistency and clarity in planetary science. Pluto joined a new category that includes other fascinating objects like Eris, Haumea, and Makemake. And scientifically speaking, Pluto remains extraordinary. It has towering mountains made of water ice. It possesses a thin but complex atmosphere that expands and collapses as it moves through its orbit. It has 5 moons, including the massive Charon, with which it forms a unique binary system. There is even strong evidence suggesting a subsurface ocean beneath its frozen surface. Pluto did not change in 2006. Our understanding did. Science is not about preserving tradition. It is about refining truth as evidence improves. When new data challenges old assumptions, definitions must evolve. Pluto remains one of the most intriguing worlds ever discovered. It simply does not meet the modern scientific definition of a planet. And that is the real reason Pluto is no longer a planet. If Pluto teaches us anything, it is this. In science, evidence matters more than nostalgia, and understanding matters more than labels.